Hi guys, it's Mrs. Tucker. Let's go on a road trip. All right, get out this placemat problem, also known as a multiple representation sheet, and let's walk through this. It says road trip, verbal representation. On the Tuckers' last road trip, they drove an average of 70 miles per hour. Create a table, graph, and equation to represent the distance traveled during this trip. All right, so let's grab a pencil. All right, Tuckers have not left the house yet. Number of hours on the road is 0. How far have they gotten? Yeah, that would be 0. Tuckers have been an hour on the road at 70 miles per hour. They've gotten 70 miles down the road. What if the Tuckers had been on the road for 2 hours at 70 miles per hour? Yeah, they've traveled 140 miles. You guys see what's happening here, right? Let's pause the video so you have time to fill out this total distance column. You guys do that on your own. All right, did your column look like mine? 0, 70, 140, 210, 280, 350, 420, 490, 560, 630, and 700. Good. All right. I need to figure out what the process is that changes this number into this number. All right? Some people call this the rule. Some people call it a process. Eventually, we're going to turn it into an equation. All right? So I know you guys see a pattern here. I know you see that we start at 0 distance and we increase by 70 miles here. And from here to here, we increase by another 70. And from here to here, we increase by another 70. And from here to here, we increase by another 70. And we could say, well, for 4 hours, at 4 hours, we've gone 70 plus 70 plus 70 plus 70. Well, there's a shorthand way of writing this. We can say we have 4 groups of 70, and that gets us up to 280, because multiplication is just repeated addition. So at 3 hours, wouldn't you guys agree it's just 70 plus 70 plus 70, or 3 groups of 70? Yeah. Do you guys see what's happening here, our process or our rule? What about if I haven't left yet? Yeah, my time is 0, I get 0. I want you guys to fill out your process column now while I pause the video. I'll give you time to fill this out. Did your process column look like mine? Okay, great. It's okay if you had, say, the 10 in front of the 70, you would have still got the same answer. So it's okay if you did that. All right? Now, let's take all of this data and let's graph it. And the thing I want you to notice is in this table, the 70 always stays the same, the multiplication always stays the same, the equal sign always stays the same. These numbers right here are changing. And what are those numbers? The 0, 1, 2, 3, 4. What are those numbers? Yeah, that's your number of hours. The number of hours is always changing. And as that changes, your total distance is changing. So that's our 2 variables. Variables are numbers that change. So we're going to graph our 2 variables in this graph. Give your graph a title. Road trip or Tucker's road trip. Your title needs to reflect what's going on here, what the data is. All right? And I gave you a hint. The dependent variable goes here on the y-axis, and the independent variable goes here on the x-axis. Here's your x-axis, here's your y-axis. And we have to decide which is our dependent variable. Does the number of hours that we travel depend on the total distance we get down the road? Or does the total distance that we travel depend on the number of hours that we travel? Which one is it? Yeah, how far we get down the road depends upon how many hours we've been traveling. This is our independent, and it's going to go on the x-axis. And total distance is our dependent, and it's going to go on the y-axis. So down here, I want you to title this number of hours and distance in miles. And all of our graphs are going to start at 0, 0. Okay, so write that down. I'll pause the video while you do that. Okay, now our number of hours, we've got to scale out our x-axis, and we've got to get from 0 all the way down to 10 hours on our x-axis. And the rule is you have to increment each line by the same amount. So if I start at 0 and I decide each line's worth 2, this would be 2, 4, 6, 8, 10. Well, I can spread that out more than that. How about if we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, let's do that. Let's make each line increase by 1 hour each time. Okay, so it looks like that. Did you get that down? Okay, now for total distance in miles, we've got to go from a low of 0 all the way up to a high of 70, or 700, I'm sorry, 700. And each line has to increase by the same amount each time, okay? So if I'm starting at 0 here, am I going to go 100, 200, 300, 400, 500, 600? I could, but that's going to make it hard to graph. I can't go by 1s, I can't go by 2s, I can't go by 5s. 5, 10, 15, 20, 20. We'll never get up to 700. What if we go by 50s? 50, 100, 50, 200, 50, 300, 50, 400, 50, 500, 50, 600, 50, 700. We could go by 50s. And some kids always say, well, if I have to increment by the same amount each time, why can't I go up by 70s? And I've never really figured out a good reason why you couldn't do that. Okay? So you decide how you want to graph it out. The only rule is you have to increment by the same amount each time. And let's pause the video so you can do that. All right. Now we're going to graph the data. This is your x-coordinate, this is your y-coordinate. I have an ordered pair right here. 0, 0 graphs right there. Here's my x-coordinate, here's my y-coordinate, 1, 70, 1, 70 goes right there. Here's my x-coordinate, here's my y-coordinate, 2, 140. Let's graph all those points. I'll pause the video while you do that. Did your graph look like mine? Great. We've got one last question before we leave the graph. Do you connect the dots? Sometimes yes and sometimes no. And I'm going to ask you this question. Do you have data in between the points you plotted? Could the Tuckers drive for 5.5 hours? Yes, they could. Could the Tuckers drive for 8 3/4 hours and get a certain distance? Yes, they could. And if the answer to those kind of questions is yes, then you connect the dots with a line. Okay? All right, great. Let's go write the equation. All right. Right here in our process, the 70 never changes, the multiplication never changes, and the equal sign never changes. Did y'all notice that? Yeah, I did too. So what changes are these values here, and you told me those values were what? Yeah, those are number of hours. And the other set of values that change are these ones over here, which is distance. Okay? So I know that 70 multiplied by this set of numbers right here equals this set of numbers here. So let's let the number of let's represent number of hours by a variable, and let's represent distance by a variable. And you get to pick your variables. Okay? Some people might say, well, since I'm talking numbers of hours, they might choose H for the number of hours. They might call this H. And since this is distance, they might use D for distance. Some people say, well, I know that distance depends upon how many hours I've been traveling, so distance graphs on the y-axis, number of hours graphs on the x, let's call it x and y. Okay, that's two very good reasons for picking different types of variables. Here we went with h and d, so I could say 70 multiplied by h equals d, my distance, or I could say distance equals 70 multiplied by h. If you had called this x and y, you could have said, well, my distance y equals 70 times my time, which I said was x. It's okay if you write it like this. But in math, when you get into algebra, the convention is if a number is being multiplied by a variable, let's always write the variable first. You always see math teachers write did I say the variable first? You always write the number first, which is called the coefficient, and the variable second. Here I've got a coefficient and a variable. We always write the coefficient first. Okay? So, now let's answer a couple questions. How far did the Tuckers travel if they'd been on the road for 12 hours? Well, it's not in the table, but you could extend the table down to 12 hours. You could extend your graph out to 12 hours, or you could take 70 times 12 and get your answer. So work up what your answer is. What'd you get? I got 840 miles. Is that what you guys got? Yeah, and which representation did you use? Well, I used the equation because I thought it was the easiest. Now, how long did it take them to travel 385 miles? First thing I would do is go back and look and see if 385 is in my table. You guys work this out on your own. And we're done with this one. That is not your bell. That's my bell. That's not your bell. So stay seated. All right? And let's compare answers and see what you got on B.